Welcome back to the Geography series. I am glad in inviting your attention to this episode dealing with types and distribution of soils. In this episode, let us understand the types and distribution of soil, which is life-giving to all plants and organisms on the earth. This episode consists of following modules. 1. Soil defined. 2. Importance of soil. 3. Nature of soil. 4. Soil pathogenesis. 5. Soil classification and distribution. Let me begin with the word soil and how it is defined. Soil defined. Soil is a natural body consisting of layers of minerals, constitutes of variable thickness which differ from the parent materials in their morphological, physical, chemical and mineralogical characteristics. It is composed of particles of broken rock that have been altered by chemical environmental process that include weathering and erosion. Soil differs from its parent rock due to interaction between the lithosphere, hydrosphere, atmosphere and the biosphere. It supports a complex ecosystem which supports the plants on the surface and creates new soil by breaking down rocks and sand. This microscopic ecosystem has co-evolved with the plants to collect and store water and nutrients in the form of usable by plants. Importance of soil. Soil is used in agriculture where it serves as the primary nutrient base for plants. The type of soil used in agriculture vary with respect to the species of plants that are cultivated. Soil material is a critical component in the mining and construction of industries. Soil serves as a foundation for most construction projects. Soil resources are critical to the environment as well as food and fiber production. Soil provides minerals and water to plants. Soil absorbs rainwater and releases it later, thus preventing floods and drought. Soil cleans the water as it percolates. Soil is the habitat for many organisms. The biological component of soil is an extremely important since about 57% of the biotic content is carbon. Soil filters and purify water and affect its chemistry. Rainwater and pooled water from ponds, lakes and rivers percolate through the soil horizon. Nature of soil. An important factor influencing the productivity of our planet's various ecosystems is the nature of their soils. Soils are vital for the existence of many forms of life that have evolved on our planet. For example, soils provide vascular plants with a medium for growth and supply these organisms with most of their nutritional requirements. Further, the nutrient status of ecosystems, soils not only limits both plant growth but also the productivity of consumers type organisms further down the food chain. The figure 1 shows the most soil contain 4 basic components, that is mineral particles, water, air and organic matter. Organic matter can be further subdivided into humus, roots and living organisms. The values given above are for an average soil. Soil itself is very complex. It would be very wrong to think of soil as just a collection of fine mineral particles. Soil also contains air, water, dead organic matter and various types of living organisms. The formation of a soil is influenced by organisms, climate, topography, parent material and time. The following items describes some important features of a soil that help to distinguish it from mineral sediments. Soil texture. The texture of soil refers to the size distribution of the mineral particle found in a representative sample of soil. Particles are normally grouped into three main classes: sand, silt and clay. Soil pH. In figure 2, the pH scale, a value of 7.0 is considered neutral. The values higher than 7.0 are increasingly alkaline or basic, and values lower than 7.0 are increasingly acidic. Soil fertility is directly influenced by pH through the solubility of many nutrients. At a pH lower than 5.5, many nutrients become very soluble and are readily leached from the soil profile. At high pH, nutrients become insoluble and plants cannot readily extract them. Maximum soil fertility occurs in the range of 6.0 to 7.2. Soil color. Soils tend to have distinct variation in color both horizontally and vertically. The coloring of soils occurs because of a variety of factors. Soils of the humid tropics are generally red or yellow because of the oxidation of iron or aluminum respectively. In large additions of humus cause soils to be black. The heavy leaching of iron causes coniferous forest soils to be grey. High water tables in soils cause the reduction of iron, and these soils tend to have greenish grey blue. Organic matter colors the soil black. The combination of iron oxide and organic content gives many soil types a brown color. Other coloring materials something present include white calcium carbonate, black manganese oxide and black carbon compounds. Soil profile. Typical layer found in soil profiles are as follows. Most soils have a distinct profile or sequence of horizontal layers. Generally, these horizons results from the process of chemical weathering. Up to 5 layers can be present in a typical soil. O, A, B, C and R horizons. The above figure shows this. The O horizon is the topmost layer of most soils. It is composed mainly of plant litter at various levels of decomposition and humus. A horizon is found below the O layer. This layer is composed primarily of mineral particles. The B horizon is a mineral soil layer. The B horizon may be colored by oxides of iron and aluminum or by calcium carbonate. The C horizon is composed of weathered parent material. The final layer in a typical soil profile is called the R horizon. This soil layer simply consists of unweathered bedrocks. Soil pathogenesis. The figure 4 shows the development of soil is influenced by 5 interrelated factors, that is organisms, topography, time, parent material and climate. Let us discuss the soil classification and distribution. Many natural bodies such as plants and animals are difficult to identify and classify than these discrete bodies for 2 main reasons. Soil is more or less a continuum covering the land surface of the earth, not a set of discrete entities, and most of the soil is below ground and therefore not readily visible. Soils grade into one another across the landscape, usually without sharp boundaries between one type of soil and another. Soil surveyors who make maps of soil have to use their skills in reading changes in the landscape coupled with auger borings in the soil to identify the nature of soil. There are several ways of classifying a soil, from the simple to the complex. A soil type may be as simple as a sandy soil or a clayey soil, and this is often the perception of many land users such as farmers or civil engineers who see it as material they have to deal with to achieve an end result, such as the growing of a crop of wheat or the building of a road. Simple classifications tend to be of local and restricted relevance only. At the other end of the spectrum is the soil scientist who needs to understand how soils have formed, which types occur, where and for what the different types of soil can be used. The soil scientist seeks a much broader understanding with the aim of underpinning the use and preservation of this important natural resource, and this has manifested itself in a number of detailed soil classification systems worldwide. There have also been several major attempts at a world classification of soil, each of which have differed in the emphasis they have given to different soil properties. Such classification systems enable soil types to be classified and identified within a national and international framework. The two most widely used international classifications are those of soil taxonomy and based on soil properties that can be objectively measured and observed, the FAO. Numerous classification systems are in use worldwide. We will examine the systems commonly used zonal and the system used in the United States. Classification of soil. Soils are classified as zonal classification. Zonal classifications are further divided into zonal soils, intrazonal soils, ozonal soils. USDA classification. Zonal classification of soil is subdivided into the following groups. 1. Tundra soils, podzols, grey-brown podzolic, prairie earths, red and yellow forest soil, red tropical soils, laterite soils, chernozem, chestnut brown, and xerazim and red desert soil. Let me explain the zonal soil. 1. Tundra soil. Tundra soil are found along polar margins in tundra region. A soil moisture remains frozen for greater part of the year and chemical and organic changes are slow. Fertility in this soil is very low. Podzol soils are distributed in North America and Eurasia. The fertility is low and productivity is also low. Grey-brown podzolic soil are found in mid-latitude deciduous forest on western margin of the continents and parts of Eastern Asia such as Manchuria, Korea, Japan, Western Europe and northeastern United States. Soil fertility is reasonable and productivity is high in this soil. Prairie earth soils are distributed in parkland areas of temperate grasslands region. The fertility and productivity is very high and it contains high humus content. Red and yellow forest soil. These soils are characterized by little humus content and are very susceptible to erosion. The productivity is high due to medium fertility. This soil is mainly found in southeast USA, southeast China, south Japan, southeast Brazil, east coast of Africa. Red tropical soils are found in tropical regions including Asia, Africa, Australia and South America. The fertility of this soil is low. Laterite soils. This soil is found in Brazil, West Indies, tropical Africa, South India. Chernozem soil is distributed in Ukraine and adjoining parts of CIS, Canadian Prairie, Dakota to Texas in the South USA, Pampas of North America, Murray-Darling Basin of Australia. This soil is also called black earth. Chestnut brown soil are distributed arid margins of Chernozem belt. It is less fertile than black earth. Xerazim soil. This type of soil is found mid-latitude continental deserts of Nevada and Gobi. Red desert soils are distributed in Great Desert of Australia and Africa. Intrazonal soil. These types of soil represents extremes and show the near total dominance of one single local factor. This is normally parent rock type or extremes of drainage. Because they are not related to general climatic controls, they are not found in zones, that is because they are due to say extreme rainfall. They can occur in any of the zonal or ozonal type. There are three major types and two of which have further subtypes. Calcimorphic or calcareous soils develop from a limestone parent rock. Hydromorphic soils are those which have constantly high water content. It also has two subtypes, glaze soils and peat. Halomorphic soils have very high level of soluble salts and develop through the process of salinization. Ozonal soil. These types are in direct contrast to zonal soil. They have much more recent origin and are said to be immature because they occur in areas where soil forming process have not had much time to operate on the parent rock. Due to this, the soil show very distinct characteristics of their parent rock and agent of deposition. United States soil classification system. The first formal system of soil classification was introduced in the United States by F. Marbut in the 1930s. The most general category of NRCS soil classification system recognizes 11 distinct soil orders. They are oxsoils, aridosols, mollisols, alphisols, utisols, spodsols, antisols, inceptisols, vertisols, histosols and andisols. Oxysols develop in tropical and subtropical latitudes that experience an environment with high precipitation and temperature. Aridosols are soils that develop in very dry environments. The main characteristics of this soil is poor and shallow soil horizon develop. Mollisols are soils common to grassland environment. Mollisols have a dark colored surface horizon, tend to be base rich and are quite fertile. Alphisols form under forest vegetation where the parent material has undergone significant weathering. These soils are quite widespread in their distribution and are found from southern Florida to northern Minnesota. Ultisols are soils common to the southeastern United States. This region receives high amount of precipitation because of summer thunderstorms and the winter dominance of the mid-latitude cyclones. Spodosols are soils that develop under coniferous vegetation and as a result are modified by photosynization. Antisols are immature soils often associated with recently deposited sediments from wind, water or ice erosion. Inceptisols are young soils that are more developed than antisols. These soils are found in Arctic region. Vertisols are common in areas that have shale parent materials and heavy precipitation. Histosols are organic soils that form in areas of poor drainage. Their profile consists of thick accumulation of organic matter at various stages of decomposition. Antisols develop from volcanic parent materials. Finally, let me brief the whole episode as follows. There is an enormous diversity of soils across the world. This is hardly surprising given the fact that soil formation and soil types are influenced by several key factors. The parent material, usually rock or sediment, but occasionally organic materials such as peat, climate, particularly temperature and rainfall, vegetation and other biota, topography, relief, time and increasingly the influence of humans. All these factors will have an influence on soil development and hence soil type. The potential for different combinations of these factors across the world is immense and hence it is not surprising that there are many thousands of different types of soil in the world with different properties and potential. The classification of plants that is in regular use today over the centuries, attempts have been made to develop classifications of soil on the basis of their properties, their genesis and in some cases their use potential. Since the late 19th century, there have been several national classifications developed and used. Most countries now have a system of nomenclature for their soil types. These classifications have grouped together similar soils and given names to the soils in the various classes. The classifications are mostly hierarchical in the sense that they consist of a number of levels starting at the top with a number of major divisions which can be subdivided into further subclasses and degrees of complexity. Hope this episode provided you the details required to you all. Thank you.